have Raj from Florida DOT to present us with roadside equipment and backhaul communications. Raj?
Thank you, Neelu. Thank you all for the opportunity to present on the Florida DOT's signal phase and timing deployment, the first one that just got completed and was operationalized, and that is what we would like to present today. But before we do that, I just want to give you all a quick overview of where we are with how this project has begun and what all we have done to get here. Neelu, I want to go to the next slide. Neelu, can you advance the slide?
Yes, that is also available through the red, the right arrows that you see on the screen, just so you know.
Okay. So yes, as we just mentioned, we're going to go ahead and talk about the agenda. The goal is to present to you very quickly what is AASHTO's SPAT challenge. Most of you probably are very familiar with it anyway, but we'll just touch on it real quick. We would like to explain to you what the Tallahassee SPAT project has been all about, and the various technologies that have been deployed, some of the testing that has taken place here, and the deployment considerations. The Tallahassee SPAT project, or the project that was implemented recently, is a part of the Florida DOT's Connected and Automated Vehicle Initiative. And what you see in front of you on this slide is a snapshot, or Table 5, from our TSM&O, Transportation System Management and Operations, TSM&O strategic plan that was adopted as of August of 2017. We have identified 6 primary focus areas, and one of the focus areas happens to be connected vehicles. And the whole point behind this is to indicate that connected vehicles is not necessarily a standalone effort. It is not a silo effect as much as it builds on several other efforts that have already taken place, including a very strong ITS, Intelligent Transportation System program in the state of Florida. It builds on the ITS cost feasible plan. And last but not the least, it is consistent with Florida DOT's 2017 TSM&O strategic plan, which we are beginning to implement in the state. This is also in line with the statewide Arterial Management Program, or STAMP as we call it in Florida. We just completed the 2018 STAMP action plan, or the first action plan of its type, and you will notice on this particular slide that we put a lot of emphasis on outcomes and performance assessment. And to accomplish the outcomes and performance assessment, we do want to get into traffic control strategies. We want to get into field technology deployments, traffic management center technologies, operations, and maintenance. And in the green box, you will notice that there's a significant amount of emphasis on traffic signal technologies, or adaptive signal control technologies, connected vehicles, freight signal priority, etc., connected vehicle traffic signal systems, transit signal priority, bicycle pedestrian safety, etc. And the reason why we put such an emphasis on the connected vehicle program in Florida is because of 2 specific objectives: safety and mobility. We know that it is easy to say, let us do safety and mobility through connected vehicles, but at least in the state of Florida, our goal is to embrace emerging technologies as a way to make a dent in the safety concerns that we have. For example, bicycle pedestrian safety is a major cause for concern in the state of Florida and elsewhere in the country as well. We do believe that technologies such as passive pedestrian detection can play a significant role in this. So the slide that you see in front of you is the Florida DOT's Connected Vehicle Initiative. We identify 16 specific projects or initiatives that are underway in the state, and you will see in the green number 1, that is the Tallahassee or US 90 project, which I'm going to go into some detail now. As we speak, we have a second SPAT project which is on the street. We have issued a request for proposal for the Gainesville project, which is at the University of Florida campus, and that project is advertised, and we are waiting to select a vendor, which should be completed in the month of July. And as I mentioned at the outset, most of us are familiar with AASHTO SPAT challenge. I'm not going to go into details, except to say that the challenge calls for 20 signalized intersections with SPAT information or SPAT deployment with 20 intersections per state in the 50 states by the year 2020. That totals 1,000 intersections by 2020. Here is the Tallahassee SPAT project. It extends from Duval in downtown Tallahassee up to I-10. It is a total of 21 intersections on what is called Tennessee and Mahan Drive, pretty much from downtown Tallahassee up to I-10 or Interstate 10. The key note about this project is that this is being done in close partnership with the city of Tallahassee, and we greatly appreciate their support. In fact, my supervisor, Mr. Fred Heary, is instrumental in conceptualizing this project, and we do believe that this project has really been a game changer for us. It is a small but a very significant part of the Florida DOT's Connected Vehicle Initiative. I'll go into details on the project, but in general, we completed the vendor selection in the October-November timeframe of 2017, and we just completed the deployment of the roadside units. We obtained 4 roadside units, 4 onboard units, and 2 multi-channel test tools. Integration has been a significant component of this project as we look back, and I'll try to touch on some of those elements. So when we get questions from other states on what kind of questions should be asked prior to installation and deployment, we always suggest that it is important to ask if there's anything that needs to be installed physically or hardware and of course software to the existing infrastructure. The answer is very obvious, and the answer is yes. But the question is, what infrastructure are we really talking about? It is important for any new deployer to know exactly what is being deployed and what is being installed, whether controller space is adequate or not. In the interest of time, I'll move quickly and always ask us questions. We also need to know how the controller will be communicating to the roadside unit, whether the roadside unit should be placed on the vertical of a mast arm, or whether it should be on the placed along with the antenna itself at the middle of the intersection above on the horizontal portion of the mast arm. So questions of that type are simple but very important. And here's the key: map data files. At the end of the day, even though we call it a SPAT project, map is a significant and the main ingredient of any SPAT project. So understanding as much information as you can about map data is also the key. And that means what kind of map data are being collected, where will the map reside, etc. These are questions that should be considered. This is a pretty straightforward slide, but the reason why it is here is just to show that most of the controller cabinets are pretty busy. They have very little space. So it is always important to ask the question on what kind of infrastructure or what kind of equipment would be brought to this to the table when you do your roadside unit when you do your SPAT deployment. And that means we all need to ensure that the traffic controller, both firmware and the space, would be adequate enough to deploy a sustainable system and a good system. From a roadside unit standpoint, there is definitely a lot of configuration that needs to happen before the installation. I have to say that when we say integration, or when we talk about integration, this is the kind of detail one needs to be completely aware of. The MAC IDs, the IP addresses, and any unique attributes. So technical skill set is absolutely important, and it is always helpful if the local agency or your partner is actually keenly aware of the technical details, including the IP configuration, and therefore the network details really become important. Here in Tallahassee, at several intersections, we needed more than one roadside unit. Even though the roadside units are omnidirectional, in other words, they can look in all directions, 360 degrees around, they are line of sight constrained. So if you happen to have landscaping or the roadway geometry, which is going to affect the directionality from the roadside unit to the oncoming vehicles or vice versa, obviously we may need to have more than one roadside unit. So in Tallahassee, at the 21 intersections, we deployed 34 roadside units. So you can understand, you can see that at several locations we had more than one, obviously 2 roadside units. And therefore a good comprehensive field review before or during the planning stage is a very important element of the project. Let's see. Just one other quick point, some basic details which every traffic engineer is keenly aware of, ensuring that all the devices are properly secured and they're in a watertight compartment type of detail is essential. Just a few pictures of some installation we did during the pre-deployment testing at our Traffic Engineering Research Lab. That is what TERL stands for, Traffic Engineering Research Lab here in Tallahassee. TERL is responsible for evaluation of all the equipment that goes onto the public roadways and becomes a part of the approved product list or APL. Here are the roadside units that are deployed in the field. You can see that the roadside unit along with the antenna is actually deployed on the horizontal or the mast arm as to the extent possible in the middle of the roadway so that it can get the maximum visibility in both directions. Here are the antennas that are mounted on the vehicle which receive the information from the roadside units. So that's what the pictures show. Multi-channel test tool is a very important element to understand. A multi-channel test tool is typically used to verify the signal strength and the quality, and also to make sure that the data that is displayed, that is to be displayed, is in fact received from the roadside units. Multi-channel test tools can be DSRC radios that are reserved specifically for use and configured, of course, to detect the roadside unit messages, either with a laptop or another device. And as I mentioned earlier, it is important to understand how to use the roadside units, onboard units, particularly the onboard units and multi-channel test tools, particularly from a MAC and IP address standpoint. In fact, all it takes is one digit to be off and we are not going to receive the data. So quality assurance is an important part of the equation. Onboard units, in our particular case, Android tabs were the onboard units for the display purpose. However, I'll explain to you in a couple of slides down the road on what an onboard unit looks like. The onboard unit configuration varies. Some manufacturer OBUs do not require an external computer. Obviously, we need to ensure that the OBUs can process. This is an important point, the second bullet. We need to ensure that onboard units can, in fact, process and handle the avalanche of messages that come from the roadside units in the field. It could be overwhelming at times, and that is the reason why a good integrator would understand the fine-tuning elements at the field level. I mean, it sounds much simpler, but once we get to the field, one can understand the gravity of the situation. Obviously, it is important to designate and configure the units before any installation takes place, and that's where the testing is an important element. These are pictures we took from our deployment. Onboard units, as I mentioned earlier, can comprise a dedicated short-range communication radio and GPS that is in turn connected to a Raspberry Pi, and it also includes a cellular modem. It's a Netgear that we had, and a router with Wi-Fi that is in turn connected to a tablet. So that is how our vendor had actually custom built the Roads onboard unit for our use. We purchased 4 onboard units as a part of this project. In an ideal world, it would be nice to have as many as we possibly can. This is a picture from a pre-deployment testing. You can see the green time. There's 3 seconds left here in this particular case. For the left turn, there's 12 seconds left at the other intersection. Here's a small video I'd like to run for you. Maybe not this one, but let's see. These are all, as I said, these are all pictures from the field deployment we had. For some reason, I'm not able to run the video of this particular slide, but anyway, this was supposed to be an 80-second video, it's a 30-second video, which we're not able to run at this stage. But basically, this video would have shown that as you're driving up to the intersection, the actual clock down takes place, and then once the yellow turns on, then you'll be able to see the display as well. There's obviously the messages, the SPAT data keeps rolling in, one would be able to see it during the field testing and deployment. Long story short, we have some lessons which we learned from the project. The Federal Communication Commission licensing system is a key. For those who do not know the FCC licensing process, it is on the one hand pretty straightforward, but on the other hand, it is important to know what it is all about. First, there is a blanket approval for the use of DSRC, and then after you select your vendor, that is when we need to provide to the FCC a comprehensive list of the exact location, including the GPS coordinates, the mounting height of the devices, the make and model of the roadside units and onboard units, and get that second approval before we can actually operate the system at the field level. We need to ensure that the devices are in fact licensed by FCC for use on the project, so the devices should be FCC certified. The proposers should ask questions during the procurement process regarding device compatibility with controllers. I mean, this is probably easier said than done, whether your MIBs are capable of being provided or not. So the controller elements need to be carefully considered when the project is being designed. Map data, as I mentioned earlier, ensure that the map data are properly coded and the Uber hex code is in fact validated for field testing. And we have done that before we put the RFP on the street, so we learned quite a bit about the complexities and challenges of map data. Regardless, even during the deployment phase, there is going to be an opportunity to, there is going to be a need, I should say, to actually make modifications to the map data at the field level. So it is important that whoever the vendor is or the service provider, they need to understand how the map data in fact work. We are planning on expanding our SPAC project and or on other projects, the deployment of other connected vehicle technologies, including bicycle pedestrian safety. With that, I'll end my presentation. That is the contact detail. Do not hesitate to reach out to us either directly or through NOCO. Nilu, I'll turn it over to you now.
Thank you, Raj. I'm gonna ask you for a link for that video, if possible, to share it later on the website so everybody can see it. So thanks for that. We will have Brian Reed from WSP now to talk about roadside units now. Brian?
Lou, thank you so much. Thank you everyone for joining our webinar today. Greatly appreciated. So we're going to kind of cover a little bit more detail, at least in